Hi, everybody. Thank you for coming to my session today. I'm going to try to explain you how Cosmos DB works under the hood. And my name is Hasan Savran. Let me speak about myself before I go in my presentation. I'm a Microsoft Data Platform MVP for 2 years now. I am from Cleveland, Ohio, United States. And currently, I am working at one of the largest insurance companies here as a business intelligence manager. And I have been doing web development almost 15, 16 years now. And my last 8 years, I have been in business intelligence business, I guess. You can follow me from any of those platforms you see on the screen. And I have written a lot of blogs about the Cosmos DB2. So check out my blog whenever you have time. So let's jump in and try to, I guess, cover everything here in 25, 30 minutes we have. So this map here you see, usually you kind of start whenever you try to create a new service in Azure. You kind of need to pick a region for it. And that kind of works for the Cosmos DB2. And this is not all data centers Azure has. I'm just using this as my template here. And so whenever you try to create the Cosmos DB, the first thing you need to pick is where you want to kind of, I guess, want your database. You want your database close to your users. So what I'm going to do here is I'm going to kind of give you a business case, and we are going to kind of figure out how Cosmos DB is going to actually handle our data in backend. So let's say we are a company and we want to build smart cars. And we have, many other models. And this year came and we figured out that our competition, all the other brands, are making their cars smart. So we say, okay, this is our year. We are going to make one of our model smart. For that, we are going to kind of put a bunch of IoT devices in the car. And we are going to able to send and receive data from the cars. For that, we go and hire a dev team, and hopefully this year we are going to have some kind of solution for that. So we are located somewhere in Central Europe. So the first thing our dev team is going to figure out is what kind of database we are going to need, because we need to store this data somewhere. And they look at our requirements, and it's pretty clear that we are going to need a NoSQL database here. Because, well, this year we have one model, but we are going to, come up with many models next year. And probably the IoT devices, the schema is not going to be same from each sensor. So it's pretty clear that we are going to need a NoSQL database here. So our dev team look at the options, and then they figure out that, what, there's a new product here and named Cosmos DB, and we are going to give it a chance. Let's see how it's going to work out. So they started a new database from Cosmos DB, and they picked the SQL API to use it. Because, well, this is a brand new application, and SQL API has many features, and Microsoft is, in control of the SQL API 100%. So that's the one we pick. From here, as soon as our database actually becomes online and ready, our SLA becomes 99.99%. That is a great SLA for the database as a starting point. The next thing we are going to do here is, well, we need to figure out where's our users, where's our customers, right? So our dev team kind of looks around and looks at the data, who's actually buying this car. And they figure out that, well, we are selling this car everywhere. And most of the actually customers are in the United States. We have customers in Europe, and we have customers in East of Asia. So they see a problem here. The problem is we don't want people from the United States or Asia try to write the data to the Europe, because that's going to be a long distance. It's going to take longer, and a lot of things can go wrong. So our data team looks at the Cosmos DB features, and they figure out that, actually Cosmos DB has a global distribution, which means that we can actually, replicate our database very easily in different locations. So our dev team goes and says that, okay, you know what? We are going to actually make this database available in 2 places, east and west side of the United States. And we are going to pick 1 data center in Asia. So at the end, we end up with 4 locations. The best thing about this is, well, we really don't have to do or change anything. And our customers, for example, in the United States, let's say you are in Los Angeles and you are driving your car, the SDK is smart enough to actually pick the closest database to your location. So people in the United States are going to write and read the data wherever is close to them. And Cosmos DB is going to be responsible to sync this data in the backend. So everything's working great so far. Also, one more thing though, as soon as actually we made this change and we are in multiple places, our SLA actually goes up to 99.999%. We are almost 100% online, which is great. Now, what else do we know about the Cosmos DB? So as you can see, we really don't have that much information. In older days, I remember when I was maybe installing the SQL Server, we used to have disks and CDs. You put the CD in it and you kind of click next, who knows how many times, and you were customizing the database. You know how it was working, right? But in Cosmos DB, in cloud services, it's not like that. So there's a lot of kind of gray areas that we don't have any control, but it's kind of good to know how actually Cosmos DB works in the backend. So how actually Cosmos DB is saving the data in the backend is what we know. The first thing is all the disks that Cosmos DB is going to use going to be a local SSD disks. So we know that we are going to get the data fast. The second thing we know is Cosmos DB actually saves this data in physical partitions. Now, number of physical partitions is going to depend how much data you store in the database. And this is the layer that physical partitions, that we know about it, but we have absolutely no control to change anything in this layer. Microsoft manages everything in the physical partition. What else do we know about the physical partition? So if we kind of, dig in a little bit more, you will see a replica set in each physical partition. There's a 1 leader and 3 followers. And the data comes into the leader, and then it shares all the data to the followers. So whenever a web application tries to read the data, well, potentially it has 4 options to read the data. And that's one of the main reasons that why Cosmos DB is a very fast database. So as you can see, this model here, what you see here is with no global distribution. There are 2 numbers here that you kind of need to know. As I said before, you have no control of physical partition, but those 2 numbers can trigger a lot of kind of things, a lot of problems for you if you don't kind of watch them. The first one is 50 gig. That is the size limit of each physical partition. If you are going to have more than 50 gig, then that means we are going to have more physical partitions. So you kind of need to watch how much data you are storing in your database. The second one is 10,000 request units. This is the limit that this physical partition can deliver, the maximum request units. So let's say, for example, your application is going to need 15,000 request units. And that means even you don't have the 50 gig data, you are going to end up with 2 physical partitions. So whenever you try to change the request units in any time, you want to be sure that, those are the limits of each physical partition. Now, this model here is without global distribution. In our situation, well, we have global distribution. So this kind of model changes a little bit for us. In our case, we have Europe, we have 2 United States, and we have 1 Asia. So as we can see, one of the followers actually becomes a forwarder in each physical partition here. So the data comes, let's say, for example, the Europe, the data comes in, it goes to leader shares the data, and it goes to the forwarder. Then forwarder is responsible to move this data to other regions and it delivers to other leaders. So leaders gets the data, and that's how actually Cosmos DB syncs the data in the backend. Now, usually this is the point that I get the question like, well, what about the conflicts? Does conflicts happen? Well, conflicts occur in any databases, and Cosmos DB is not an exception. So there are three types of conflicts can happen. Can be whenever you are inserting data, whenever you're updating data, or whenever you are deleting the data. So whenever actually, let's say the two users, one from Asia, one from United States, try to write the same exact data. When that occurs, our referee comes from nowhere, and it just stops these two transactions. And we kind of need to figure out which data we need to trust. So if you are going to go and just go by the default, that's going to be the last write wins, which means that whoever actually write the data the last, we are going to take that data and throw the other one out. So we're going to trust that. That sounds good, but it really, the problem is most of the businesses has more complex, I guess, business workflows than that. So if that's the case, what you have to do here is you kind of need to pick the custom option. And when you pick the custom option, what you need to do is you need to create a store procedure. And you can put all the logic, which is going to actually merge this data. And you can make it complex as much as you like in that store procedure. And you need to register that store procedure as a merge store procedure. Then what's going to happen is when a conflict is going to actually occur in the system, it's going to put in a queue, and the system is going to run your merge store procedure for each of the problem and try to fix the problem in the backend. So in that case, you have full control of how you merge the data when a conflict happens. Another option here we have, another new feature is the storage. So we used to have only one storage. Now actually we have two. So let's cover the first one first, which is the transactional storage. And all the APIs of you see on the screen is actually whenever they save the data is getting saved in the transactional storage engine. And everything is actually getting saved row by row. That's why we call that row store. As you can see in the bottom left screen here, the data is getting saved by row. So usually your application is hopefully gonna search by the ID here. And as soon as it finds the ID, the rest of the data is gonna be right behind that ID row. So it's gonna be much easier to read on the disk. The disk is gonna go crazy, and everything is gonna run in linearly easily. So the next option we have, which is optional really, you can actually enable if you like, the analytical storage. What's going to happen in this case is Cosmos DB is going to move your data from the row store to the column store, which is the analytical storage, automatically. So if you are like me, because I do a lot of ETL jobs too, and I'm responsible for some of them, which can be pain. In this case, Cosmos DB is going to actually move our data without writing any kind of ETL and make it available in the analytical storage. So your reports can actually read from the analytical storage, and your application can read from the transactional storage. So that kind of gives us a nice, I guess, two environment, which is great for architecturally. Also, as you can see in the analytical storage, we are saving the data column by column. That helps whenever you try to aggregate the data. For example, if you are saving, for example, ages, and if you want to get the average of all the ages, all the ages are going to be right in the same area of the disk, and it's going to be much easier to read and find what you are looking for. And this option is available, but as I said before, it's optional, and you have to make it available to be able to use it. Other thing you should know in Cosmos DB, there are some kind of special columns in each document here. So those are the following ones. For example, _RID is the record ID, and it's the unique identifier for each item. What you need to know about those is this just doesn't apply to documents. Actually, every collection has an RID. Every database has RID. So this it works for any kind of layer of the feature in Cosmos DB. Underscore E tag is mostly used for optimistic concurrency. And we have timestamp, which is the underscore TS. Self is very interesting one here. Let's see here. When you look at the self here, and if you use the REST API, that's going to make probably more sense to you. As you can see here, our self is starting with the DBS. This text here is actually the RID of the database. We have collections. This is the RID of the collections. This is the documents, and this is the documents of collection, documents of the RID. So if you look at this text here and this text here, as you can see, they are matching perfectly. So this is great. This is almost like a pinpoint where this document is in Cosmos DB, and this is very useful, especially in REST API. The ID here is the only one that you can, I guess, overwrite. And for example, if you are saving the products in this database or in this collection, when you are creating the collection, you can say the ID is going to be the product ID. So you have some kind of control on that if you like. Next, let's try to look at Cosmos DB on one page here. So whenever you create the Cosmos DB database, you are going to end up with a couple of items here. The first items are going to be, well, you need to pick a container. So you are going to have options. You are going to have SQL API, MongoDB, Cassandra, Gremlin, and Table API. I kind of, I guess, compare those as a multi-library, right? Like it has all kind of stuff in it, and you can pick whatever you like. So each container is going to have two main items here. The first one is the items, and items can be named a little bit different depending which API you pick. For example, if you pick the SQL API, your data is going to be in documents. If you pick the Gremlin, that's going to be nodes and edges. If you pick Table API, it's going to be rows. So those names can be changing, and that's pretty important, especially if you are using the REST API to get the data, because your URL is going to change because of that. Also, in each containers is going to have the following items here. The first thing is store procedures. What you need to know about the store procedures is, well, first of all, they are in JavaScript. So you must know JavaScript to be able to actually create store procedures. The second thing you should know about the store procedures are usually good for writing data, not for reading data. The main reason for that is, if you remember that replica set that I actually showed you earlier, we had a leader and we had 3 followers. Store procedures are executed only in leaders. That means leaders already, busy with, getting data, and it's great if you are running the store procedure as inserting data. But if you are trying to read the data, well, you should actually read the data in the followers rather than the leaders. So if you want to do that, then probably user-defined functions is going to be better for you, because those actually runs and executed in the followers rather than the leader. Triggers is a little bit tricky too, especially if you are coming from SQL Server. In SQL Server, triggers are getting executed automatically. In Cosmos DB, that's not the case. You have 2 types of triggers, which is pre-transaction and post-transaction, and you have to fire them manually. And we cover the merge procedures, which are the store procedures, which is going to handle the conflicts. So as you can see, everything here is per container. Next is partitioning. Partitioning is going to be the first curve that probably you need to take if you are using the Cosmos DB. And you better take it good, because that can give you a lot of problems later. A lot of things can actually go wrong if you pick the wrong partition ID. You might end up with hot partitions, or the partition you pick might exceed the size of the logical partition limit, which is the 20 gig. And those are not really that easy problems to fix later. So you should really study your data. You should look at your where clause and be sure that you are picking the right partition, which is going to be many distinct values of whatever you are trying to save there. So There are two types of partition, as I said before. The first one is the physical partitioning. And I compare this one is like almost like an empty containership. Whenever you create a database, Cosmos DB gives you this empty containership. Only two things you need to know about this is the first thing, this can take 50 gig data. That is your limit. The next thing you need to know is its horsepower is 10,000 request units. So those two numbers, just don't forget them. I just put them here. Rather than those two numbers, absolutely you have no rights to change anything on this layer. What you can do, though, is it's going to be your responsibility to group your data and store your data in this containership. So the first thing you need to know is those containers that you see here are going to be your logical partitions, and you need to define them, what's going to be in those containerships. The second thing you need to know is those Cosmos DB likes those containers small. You don't want two big, huge containers here. Because what's going to happen is, in our case, for example, we were building cars, right? So if you are going to group your car, let's say maybe by year, well, this year you might have maybe 20,000 cars, but next year you might have maybe 100,000 cars. So it's not going to be easy to kind of group those by year. It's going to be much easier to pick something small, for example, like VIN number. So if you pick the VIN number, for example, of each container you see here is going to have one car in them. And then it's going to be much easier to read and write the data, because whenever you are trying to read the data, you're going to pass the VIN number. And if you pass the VIN number, Cosmos DB is going to know exactly which physical partition to go and which logical partition, which container actually has that car. After that, you open that container, and all the data that you had about that car is going to be in that container. So it's almost going to be like pinpointing where the data is. Partition ID, logical partition ID, will be hashed, and it will distribute your requests. It will distribute the storage, and it's intelligently route queries for efficiency. So it's pretty important to pick the right partition ID for your application. And also, you kind of need to, not all the applications are read heavy or write heavy, so you kind of need to be careful whenever you are picking the partition ID, especially like if you are doing the IoT, for example. You might not have I guess, good candidate, because those sensors usually does not have that much data. So you might need to actually create your own partition ID in that case. But this is probably one of the most important part of Cosmos DB. You want to pick the right partition ID, because that's gonna, make your application really work fast, or it's gonna make it really expensive. So you kind of need to be, I guess, pay attention to this part. Well, that's all I have for you today, and I hope you learned something new today. Thank you for joining me. And again, you can follow me from any of those platforms and ask me any questions. I will be happy to answer them. And my blog is out there too. Thank you.